Hello, my dear friends. We are live now. We are live now. So, today, my dear friends, we are gonna do elasticity, and stress, and stress. Don't take stress. This stress is easy. This stress is easy. So, don't take stress and be elastic. So, our today's topic is elasticity and stress. Pretty easy things about me. About me. My name is Raghav Sharma. My name is Raghav Sharma. Okay. My name is Raghav Sharma. And this is our goal for today. This is our goal for today. Solid. Okay. Solid. Okay. Solid. Elasticity. Some terms related. Stress. And types of stress. Solid elasticity. Terms related. Stress. And type of stresses. This is we are going today. These are the things we are rolling. So first have an understanding about solid. Okay. Because this phenomena is found in what? Solid. So we have to have the understanding of what? Solid. Solid. So if we zoom on solid, there are atoms, and atoms are held by the intermolecular force. Intermolecular force. Intermolecular force. Intermolecular force. If you apply force, and this intermolecular force, you can say it is like a spring. Spring. It is like a spring. You compress it, it will go back to its original shape. Okay. If you compress it, it will go back to its original shape. Go back to its original shape. Goes back to its, extend it, compress it. It will go back to original shape. Intermolecular force acts like a what? Acts like a restoring force. Restoring force in solid. Intermolecular force acts like a restoring force in what? Solid. And you can say, you can do the analogy of the intermolecular force with the spring system. Compress it, it goes back to original shape. Extend it, it will go back to its original shape. So this is how intermolecular force plays in solid and gives rise to what? Elasticity. Gives rise to what? Elasticity. Elasticity. Don't go for the Morse curve. Okay. Just have that, and this is fine. Okay, this is fine to have a good visualization. Now we have elasticity. Elasticity. What is elasticity, sir? What is elasticity? Elasticity is the property due to which it's regain its original shape and size after the deforming force removed. It is not, elasticity is not that how much it can, okay, and how much it can, no. It is the property to regain its original size or shape after the deforming force removed. This is called elasticity. Not that how much it can extend or how much it can compress. This is not elasticity. the property by the virtue that it can regain its original size and shape after the removal of deforming force. That is called elasticity. That is called elasticity. That is called elasticity. Like my dear friends, clear, 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 my dear friends. Am I clear? Am I clear? The property by it regains its size and shape after the removal of deforming force is known as elasticity. Not how much it can, you can extend it or you can compress it. This is not elasticity. After you remove that deforming force, if it can regain its original size and shape, that is called elasticity. Few terms related. We have deforming force. Deforming force. So what is deforming force? What is deforming force? What is deforming force? The force which tries, or change, the force which tries or change, the size and shape of the body, is called what? Deforming force. Is called deforming force. Is called deforming force. The external force which we are applying, that is called deforming force. That is called deforming force. The force that we are applying, external force, on the object which is trying or changing the size and shape, is called deforming force. Up next, we have perfectly elastic body. What is perfectly elastic body? What is perfectly elastic body? What is perfectly elastic body? Imagine, my dear friends. Imagination is the key. Imagine. You have a solid. Like this. And in which you have marked two atoms. Atom A and atom B. And the difference in their distance between them is L. Difference between them is L. And you have compressed the body. Now their length is when you compressed it, now its length become L1. The difference between the two atoms on compressing becomes L1. Okay, force applied. You compressed it, and now the length, this L, has become L1. For perfectly elastic body, after you remove this force, if this L1 become equal to L, return to its original size, shape, length, then we can say it is a perfectly elastic body. It regains its original configuration. Then we can say it is perfectly elastic body. And what about plastic body, or you can say perfectly inelastic body? What about it? if this L1, after we remove this force, L1 become equal to L, and if this L1 is not equal to L, if this L1 is not equal to L, if this L1 is not equal to L, then we can say it is a plastic body. L1 is L, L1 is L, okay, L1 is L, L1 is L1, L1 is equal to L1. After deforming, after applying deforming force, it doesn't regain its original configuration, then we can say it is a plastic body, a perfectly elastic body. When it doesn't even try to regain its original configuration, it is called inelastic body. Are we clear, my dear friends? Are we clear? Are we clear? When it doesn't try to regain its original configuration, we can say it is a plastic body. Now we have stress. Now we have stress. Now you have stress, my dear friends. You have stress. Stress. What is stress? The internal restoring force. What is the internal restoring force? That intermolecular force, acting per unit of the cross section of the deformed body, is called stress. You apply the force on the object. And the internal force comes to rescue. I will make you get your real structure back. So that internal restoring force, that is acting, the internal restoring force, not the external force, internal restoring force, acting per unit the cross section, the force which is fighting back, the internal restoring force per unit area of the cross section of the deformed body is called stress. You know, students get sometimes confused. The force which is acting, no, the internal restoring force, my dear friends, the internal restoring force per unit of the cross section. So stress, this is the sign, my dear friends, sign. Force per unit area, F by A. This is called stress. And we have three types of stress. That we will read. First is longitudinal. Okay. Second is shear. And third is volumetric. Okay, volume stress. 1, 2, 3. So first is longitudinal stress, or you can say normal stress. Okay, normal stress. STRESS, normal stress. What it does? It acts normal to the surface. Like here we are. This is what we have. Okay. If it acts normal, like stretching. Okay, like stretching. This thing is fixed. Okay. The down surface is fixed, and we are applying the force upwards. So this force is acting normal. So what it will do? This is acting on this upward surface. This is acting on this surface, and it is normal to the it is normal to that surface, then what it is going to do, what is going to happen, it is going to stretch the length, it is going to stretch the length, it is going to stretch the length. That's why it is called what? Normal stress. Normal stress. And it can happen two ways. It can stretch, extend, or it can compress. If the case is like this, the case is like this, if the case is like this, compressing, okay, now we are compressing it, so it is going to decrease the length of the body, it is going to decrease the length of body. It is normal. Normal means perpendicular to the surface. This force is always perpendicular to the surface. Longitudinal stress, or you can say it is normal stress. Longitudinal normal stress. So it is can be of two types, tensile and compressive. Tensile means it is going to extend the length. When it extend the length, and compressive when it shorten the length. Two cases can happen, extend and shorten. Up next we have volume stress. We have volume stress. What is the volume stress? Volume stress can be like this. Let's say you have a balloon. You have a balloon. You have a balloon in air. Balloon. And you have now put this balloon in water at some depth. Now there will be a force will act which will compress the balloon, which will compress the balloon, which will compress the balloon. Longitudinal or normal stress at the one surface, normal. At the volume stress, at every point, force acts normally to the surface. That is only at the one surface. Okay, only at the one surface. In longitudinal we have 6 surfaces, it is only acting on the one surface. But in volume stress, it is acting at the all surfaces, So what is now going to do? It is going to compress the balloon. What is going to do? It is going to compress the balloon. It is going to compress the balloon. So it can be written as lambda V, force upon area, and in this case we have a very good term called pressure. We can just have the value of pressure, and that is volume stress. And at the last, we have shearing stress. Normal to the one surface, normal to the all surfaces, and now we have tangential force. Now we have tangential stress. Now let's say suppose we have some surface fixed, Now we have some surface fixed. Let's say we have a book, soap cues book. Try your luck with this soap sizzler from the sun. Okay, so now what we have, this has some soap. Which type of book is this? So we have book. So when we apply a force tangentially like this, force, and we are applying this for tangentially. So what will happen? Very hard book. So what will happen? If we apply force like this on this surface? Force is acting like this on this surface. Tangentially, okay? Tangentially like this. Tangentially. This is fixed. What will happen? This will happen, my dear friends. This will happen. Oh, my drive. What will happen? Yes, this will happen. This thing will happen. This will happen. Okay. It will produce a change in the body. So it will displace this distance by, you can say, a length x. This length is L. Okay. So it is acting on this surface. This is called the shearing stress. Due to this, the shape of the body changes or gets twisted. I don't have any good book. This book is not twisting. The sun is not twisting. Like this, it will happen like this. Not happening. So you can just imagine. It's like have some displacement. This point will displace and this point is fixed. So this, you can say, will create a displacement theta. Strain, we will do that. So this is called the shearing strain. Tangential stress. Volume normal to the every surface. Okay. And longitudinal normal to the one surface. Are we clear, my dear friends? Are we clear, my dear friends? Are we clear? Yes. I hope you have understood those easy topics. Easy because those are this physics is easy. Physics is easy, my dear friends. I hope we will do another topic, good topic. Okay, in next lecture. See you soon. See you on the next lecture. Till then, take care.